Okay, for this video we're going to cover two related topics. One is using z-values to solve problems, and the other one is using z-values with simultaneous equations to solve problems. These are often problems where we're given part of the information but not quite enough, and we've got to use the standard normal to be able to solve them. Let's have an example of the sort of problem we could do this with. Okay, if we get told that 34% of all carrots in a particular setting weigh more than 210 grams and that the mean size is 190 grams, and we want to find the standard deviation. For this, we've got, of our basic bits of information, we need to know our range, our maximum, our range, our probability, our mean, and our standard deviation. Those are our 4 bits of information. We need to have 3 of them to be able to solve this problem. So we do have that. We have our probability, we have our range, and we have our mean. The standard deviation is the last one, so we're going to put that together. Now, in order to do this, what we need to know is how many standard deviations away from the mean would 34% be. So if I look at our standard normal curve, we're looking for the top 34%. Right. And so what we're going to do is we're going to pretend that the mean was 0 and the standard deviation was 1. And if we look at it when the mean is 0 and the standard deviation is 1, we can then do an inverse normal, and we want our tail to the right with an area 0.34. So 34% or more than that. Our standard deviation is 1 and our mean is 0. And that tells us that this number here is our z number, is going to be 0.412. .41246. Let's go. Give us 5 digits. 5 digits is always a good place to start. So we know that that's how many it's 0.41246 standard deviations away from the mean. That's by using the standard deviation of 1, the mean of 0. And that's found out how many standard deviations away it is. In other words, that's our z value. So this is effectively a z-axis. Now we're going to want to convert that to an x-axis. So we know that this is 190 and this is 210. And we want to know what the standard deviation. So we know the difference between 190 and 210 is 20. And that equals 0.41246 standard deviations. So in order to solve the problem, we're just going to go 20 divided by 0.41246 to get the standard deviation equals 48.48955 or 48.5. grams. 48.5 grams. And that's our standard deviation. So the way that we did that is, first of all, we imagine that we were a standard normal, which a standard normal is where the mean is 0 and the standard deviation is 1. That told us how many standard deviations away from the mean 34% is. Using that, we then translate that to how far is it, what's the distance between our mean and our x, and we knew that that was the same number of standard deviations away from the mean. So that distance of 20 was 0.41246 standard deviations. Now there's a formula that we can use And this is a formula you get given in the formula sheet. Z equals x minus mean divided by the standard deviation. That's the format it gives it to you. But the way that I find is really helpful is this. Z times the standard deviation plus the mean. In other words, x is, well, the mean plus z times the standard deviation. So the mean plus how many z's we are times the how many z's we are times the standard deviation. It's how many standard deviations away from the mean something is. Okay, let's have a look at another problem that we can solve using this technique. Okay, this is quite a long question, but a spaghetti canning machine puts spaghetti into different sized cans. The amount that it puts in is a normally distributed random variable with an adjustable mean and a standard deviation of 11 mils. The containers that are labeled 240 mils can actually hold 300 mils to allow for any extra. So they make sure that it's bigger than what the packet is. Just like there's always that little bit at the top of a can of Coke or a bottle of drink or anything really. They put a little bit extra in there to make sure that it doesn't overflow. Right? The mean's always set above the target so that most of the time there's more spaghetti in the can than is advertised. On one particular day, they found that 14% of the cans were overflowing. What was the mean set to, and what should it be adjusted to in order to reduce the number of cans that overflowed to less than 2.5%? Okay, so we've got a couple of parts to this question. The first thing I always do whenever I'm doing a question like this is I draw my standard normal curve. Right, and we know that 14% of the cans were overflowing. So that's 0.14. And I want to know how many standard deviations that is. So I'm going to get my calculator out. I'm going to go into distribution mode and inverse normal. I'm going to set my mean to 0, my standard deviation to 1, my area to 0.14 and the tail to the right. And if I do that, I find that it's 1.08. So my Z is 1.08. That means that the mean is 1.08 away from the size that it's starting to overflow. 1.08 standard deviations away from where it starts to overflow. So we know it's going to overflow when it gets to 300. So on our x-axis, this is 300. And I know that my standard deviation is 11. So that means that I'm going to go 300 minus 11 times 1.08. I can just use the answer button in my calculator to get it to a couple more digits. And I find that my Z, my X rather, the mean has to be 288. .1. So that means that our first part the mean was set to 288 mils. Alright. The next question asks us, what would it have to be set to in order for it to be less than 2.5% overflowing? So again, we're going to draw the same thing. Oops. Going a little bit too fast for the computer. Right, that's going to have to do. The third time. So we know that this area here that's shaded is going to be 0.025, 2.5%. And so again, what we're going to do is we're going to work out what our standard normal, what our z is. So we've got our z-axis here. And for the z-axis, again, we're going to put our standard deviation to 1, our mean to 0, and our area to 0.025. And so we find that this one here, oops, undo that. For this one here, our z is 1.96. So that 300, again, so on our x-axis, our 300 has to be 1.96 standard deviations away. Now we know that we have 11 as our standard deviation. So 1.96 times 11 is 21.56. So therefore we have to go 300 minus 21.56 to get, it should be set to 278.4. 278.4 grams. Not grams, milliliters. Right. And that's how we do these sort of problems. Okay, here's a more interesting question. Right, we've got 9. This is from the Wellchild New Zealand books. This is according to New Zealand Ministry of Health. They put out a guide as to where people's growth is sitting for babies. Right, and they've got certain lines on this. You can follow that. And these were the two that were easy to read off the graph. Was it 9% of 9-month-old boys are less than 66 centimeters tall, and 25% are taller than 73.5 centimeters. Find the mean and standard deviation for the length and height of 9-month-old boys. So the first thing that I do is I draw my graph. Alright, now obviously this graph isn't perfect because the computer's stuffed up there. It actually doesn't matter. It's given me enough information that I can work off it. 0.09, and then here I've got 25%. Alright, so I've got a couple of different standard normals that I'm going to find. Alright, so I'm going to go into the inverse normal function. I'm going to find 0.25 with a tail at the right, and I find that equals 0.674. Next, I'm going to just keep the 1 and 0 for my standard deviation of mean and put 0.09, but I'm going to change my tail to the left. And something interesting is about to happen here. My z value comes out as a negative. Now that's what we'd expect because it's going to be less than 1. But we have to make sure we actually put it in as a negative. If we don't do that, 1.341. Okay, so we now need to put in our x-axis. And we have some things that we know. So going back up here, we knew that our 9% line was 66 centimeters. And our 25% line is 73.5. Alright, so this gives us a chance to set up a couple of equations. Now, you can use the equation that's in the formula sheet, but the one that I find is a lot more useful is that x is the mean plus z times the standard deviation. So here I've got 66 equals the mean, which I don't know yet, plus z, which in this case is negative 1.341 times the standard deviation. And for my next one, I know that my x is 73.5, and that equals my mean. Plus 0.674 times the standard deviation. Now, the trick to doing this is to use the standard deviation mode on the simultaneous equations mode on the calculator. And to do that, I need to rearrange the equations slightly, just slightly. I'm going to have x. I'm going to call my mean x, and my standard deviation is y. And then I need to make sure that the last bit goes at the end, because that's how the calculator puts it in. So I'm going to have it written like this: x minus 1.34y equals 66. X plus 0.67, that should be a 1, 674 y equals 73.5. Now I could solve it manually. I could go through the algebra of doing that, but I think at this point here it's probably just better to bang it in the calculator. So I'm going to go into equations, and then I'm going to go simultaneous equation, which is F1. There are two unknowns, and then I just put the numbers in. I see there's 1x, negative 1.341 y's, and 66. Then I've got 1x and 0.674 y's equals 73.5. And putting it in there, it puts out x equals 70.99, and y equals 3.72. Right, now those are much too accurate numbers, so when we put it in context, the mean is about 71 centimeters and the standard deviation is about 3.7 centimeters. And so once we work that, we can then use those numbers to calculate all of our numbers, all of our percentiles for any baby. Right? So that's how we do one of those problems. Here's the one for you to do. Okay, here's your next problem. 7% of all taxi fares in John's taxi are less than $13. 22% of all fares are more than $31. What's the probability that the next ride costs more than $40? You're going to have to use the standard normal to create a set of simultaneous equations, use those to find the mean and the standard deviation, and then the last thing you're going to have to do is you're going to have to use that mean and standard deviation to work out a normal normal distribution problem to find the probability that x is greater than 40. Good luck!